Ladies and gentlemen, this is Freddy Madonzella and welcome back to my channel. So in this video we'll be discussing in integrals. So in the last video we dealt with differentiation. So now when we speak of integration, we move from integrals to differentiation. So we know that when we are finding dy dx, we used to say a multiplied by n x to the power n minus 1. So we knew that n is an exponent, and we knew that it was our coefficient. So now, since we are doing integration, so that means if we are having x to the power n, because of in differentiation we are minusing n on our exponent, so that means in integration we will plus n in our exponent. So therefore let's look at the first rule. So looking at the first rule, we will say that if I'm having an integral x to the power n, the integral of this, it will be x to the power n plus 1 divided by n plus 1 plus c. So in this case c, it will be our what? Constant. Then let's look at the second rule. So the second rule says that if I'm having an integral of k, so which k is our integer. So since k is our integer, so that means when we integrate in our integer, we'll get k multiplied by x plus c. So someone will ask themselves, why do we put x now? So now, if I'm having k only, that means it's multiplied by 1. So therefore, we know that x to the power 0 is equals to 1. So therefore, since we add our 1 on our exponent when we are doing integration, so that means we'll say x to the power 0 plus 1 divided by 0 plus 1 is equals to x. So that's why we have x now when we are integrating our integer. So now let's go to rule number 3. So let's say now I'm having two functions, and I want to integrate. So I can integrate, but first I need to give each function its integral sign. So I will have an integral f at x plus an integral g at x. So therefore the last rule, I would say, let's say now I'm having an integral. So in this case I will have, let's say I'm having an integer multiplied by a function. So let's say our function is f at x. So before I integrate, I will have to first take out my integer. Then on the other side of the integral, I will be left with f at x. Then I can integrate. So now let's go and look at our examples. So example 1. So saying we are asked to find an integral of x cubed plus 2 dx. What can we do here? So the first step, we need to apply the rule, but let's first say f at x is equals to x cubed and g at x is equals to 2. So therefore, since we have chosen our f at x and g at x, we can apply the rule that says if I'm having an integral of two functions, let's say let's say f at x plus g at x. So that means we can give each function its integral sign. So plus g at x. So therefore we can apply our rule and say our integral of f at x, it will be x cubed plus an integral of g at x, it will be 2. So therefore now we can say we'll use the first rule where we say x to the power 3 plus 1. Then we divide 3 plus 1 plus 2x to the power 0 plus 1 over 0 plus 1 plus c. So now our final answer will be x to the power 4 over 4 plus 2x plus c. So this is our final answer. Example 2. So let's say we are having an integral t squared plus t over t squared. So the first step that we need to do, we need to separate our terms because of we are having a common denominator. So therefore that means we'll have t squared over t squared plus t over t squared. So therefore that means our integral is equals to 1 plus 1 over t. The reason is because of t squared will cancel t squared, will be left with 1. Then t will cancel t, will be left with 1 over t. So now to integrate this, we'll say the integral of 1 plus the integral of 1 over t. Then we will say the integral of 1 is x plus the integral of 1 over t is ln t. So because we haven't discussed logarithms, I would say, remember, if we move from integration, from integrals to differentiation, I would say if I'm asked to look for dy dx, or rather dy dx of ln x is 1 over x. The reason for that is because we said that in order for us to have ln, we need to have f prime x over f at x. So in this case, we will say our f at x is equals to t, and our f prime x is equals to 1. So therefore, if we apply this formula, we will have 1 over t, which gives us ln of t. So therefore, our final answer, it will be t plus ln t. So here we can remove it and put, we can remove this and put t. I made a mistake. So plus c. So this is our final answer. I thank you.